Finally, we have operational functions and composite functions, and this is going to be a very short one. So all it is you have a f of x, you have a g of x, and you're just doing operations on them. So plus, minus, multiply, divide. All it's saying is you're just adding them, subtracting them, multiplying them, dividing them. That's it. It's literally like easier, way easier than you think. It's just take this, do whatever operations on it. X squared plus x plus 2, that's all you can do. X squared minus x plus 2, it's in brackets, so you just flip both sides. X squared times x plus 2, you just give this x squared to all of them. U plus 2x squared. X squared divided by x plus 2, you really can't do anything about it. That's your new functions. Now, if you're trying to do it on a graph, all you do is you do the same function to your y value. So this is the same functions we have here, x squared and x plus 2. So if we're adding, let's take 0 for example. So at 0, our value are y values are 0 and 2. When you add them, it becomes 2. Subtract them, it becomes negative 2. Okay, multiply them, it becomes 0. Divide them, it becomes 0. Okay, so like if our x value was -1, let's say. Okay, when our x values are -1, this is gonna equal 1 plus 1. Okay, 2 is gonna equal 1 minus 1, which is 0. 1 times 1 is 1. 1 divided by 1 is 1. So you can just find these points from the graph by doing this the, what do you call it, function or whatever on the y value of the same x. So on positive 1, you would take the y values 3 and 1 and do the functions on it. So it's just that easy. With domains, all you do, you take the domain of this, you take the domain of this, and see where it overlaps. So the domain of radicals, remember, it has to be greater than 0. So it's x greater than -4. For this one, it's just xer. So where do they overlap? Well, they overlap right here. So our final domain is going to be x has to be greater than -4 for all of these. Now, the only thing that's different is with f divided by g of x. Since g of x becomes a denominator, it also cannot equal 0. So we just plug that in. X plus 2 cannot be equal to 0. X can be -2. So for our division one, our domain just has that little thing added to it. Now with composite functions, okay, composite functions are gonna they don't get composite and multiplication confused. Multiplication is a closed dot, composite is an open dot, and that just means doing the function of a function. So let's say f of x is x squared plus 1, and g of x is root x plus 1. F of g of x just means you're doing f of whatever g of x is, root x plus 1. So you plug this root x plus 1 into that x, and it becomes root x plus 1 squared plus 1. So that's just x plus 1 plus 1. It's x plus 2. Now to find the domain of these functions, it's still the overlap thing, but the two things that we check for overlap, we don't overlap this, because now instead of f of x, it's f of g of x. So the first thing that can't be undefined is the x plus 1, the g of x, which is the inside function, and the second thing is the whole function can be undefined. So our last function. So these are the two that we check. So for this, our restriction is x has to be greater than -1. For the final function, it's xer. Okay, then do it again, check the overlap. We already did that. So x has to be greater than -1, and that's it. Now for solving composite functions, it's pretty straightforward. If you have a table, well, you go step by step, inside out. So g of 2, well, g of 2 is 3. So this becomes f of 3. And f of 3 is 4. So this becomes 4. And same thing, f of 0. Well, in this case, there is no 0, right? So it's not in the domain. So this becomes undefined. Okay? F of 1. So f of 1 is 3 and f of 3 is 4. Okay, now with this f of g of x is 2. Now there could be multiple answers because now we have to work backwards. Okay, So f of what makes f of x equals to 2? What x values make it 2? Well, x could be either 4 or 5, right? So this could be either 4 or this could be 5. That means g of x is either 4 or g of x equals 5. So when is g of x 4? G of x is 4 when x is 1. When is g of x 5? Well, as you can see, it's never 5. So this is not a possibility. So our only answer is 1. Now same thing with the graphs. It's the same thing. F of negative 1, this is f of x. F of negative 1 is 1. So this becomes g of 1. G of 1 is 3. So the answer is 3. Now f of g of 1, again, now it could be multiple answers. So f of x, where is f of x 1? Well, it's here and here. So this can be either positive 1 or negative 1. So that means g of x is either positive 1, g of x equals negative 1. When g of x is positive 1, the x value is negative 1. When g of x is uh, negative 1, the x value is negative 3. So our two answers is x equals negative 3 and negative 1. Okay. Now a little bit of review from unit 1. It's inverses. So inverses using composite functions. Well, we know that if two functions are inverses, then f of that function is gonna be x. So if we look at these two functions, 2x minus 3 and x plus 3 equals 2. Well, if we find the inverse of this, you remember how you flip the y and flip the x. So it becomes x equals 2y minus 3. Now you isolate the y and you get y equals x plus 3 over 2, which is g of x, right? So these two are inverses, and another way to check it is by doing the composite function. So you plug g of x into f of x, becomes f of g of x, which becomes this, and it all should cancel out to x. And that's it for this unit.